Alright, so right now we're going to talk about buoyancy. So, buoyancy. And what exactly is buoyancy? Buoyancy is something that you might have heard of before. We like to play on the word a lot when we talk about buoys and things like that. So what do? They float. So buoyancy is really just talking about the ability to float. If something is buoyant, then it will float. And floating it's actually a pretty complicated thing that we're about to talk about. And it really boils down to the buoyant force. So then we have a new force that we're dealing with. And if you think about it, maybe we have some water here, and we're going to put a boat in the water. Yeah, it's a nice boat right there. Okay, well, the boat obviously is not sinking, but we know the boat has got a very large mass, and so it has a very large force of gravity that comes down off of it. So why is it not sinking? Why is it just sitting at the surface of the water? Well, that's because we have the other force involved that's pushing up on it, and that is the buoyant force. So what exactly is a buoyant force? The buoyant force is an upward force, so it does have to be upward, or towards the surface, I guess is a better way of saying it, that's exerted on an object by a surrounding fluid, so by a fluid. Okay, remember, a fluid could be a gas or a liquid. So that's the buoyant force. So we have the ship that's sitting in water, but if we take a rock and we throw it into the water, so here's the water, and we take a rock and we toss it in, then that rock is probably not, that's a really horrible rock, that rock is probably not going to float. It's probably just going to sink. So what's the deal there? Well, here it's surrounded by a fluid. The fluid is definitely in contact with it. We do have a buoyant force, and that buoyant force would be going up on it. But it has a force of gravity, and in this case, the force of gravity outweighs or is more than the buoyant force. Okay, so if something is sinking, then the force of gravity of an object is bigger than the force, the buoyant force. But over here, when we're floating, then the buoyant force is actually equal. It's equal to the force of gravity. So this buoyant force seems to be something that can shift in size and can either be more or less than gravity, and that depends on whether something is going to sink or float. So where exactly does the buoyant force come from? Okay, well, if we think about the boat, we have our water right here, and we put that boat back in the water. Okay, there's our boat. What happened when we put the boat in the water? Well, all of this, because we know the boat doesn't just sit right on the top of the water, but all of this water that you see right there had to go somewhere else. It had to go somewhere else. It had to be pushed out of the way. So it was pushed out of the way while the boat is being put into the water. Okay, well, Newton's third law, right, our favorite law there, Newton's third law says that if you push on the water to get it out of the way, then that water is going to push back on you. So you push water, water pushes back on you, and that's exactly where the buoyant force comes from, that water pushing back on the ship. So why is it that the ship was able to float, the water pushing back on it is more, or is enough to keep it from sinking, while in the rock's case, the water pushing on it wasn't enough to actually keep it afloat? Well, what's different between a ship and a rock? Well, obviously the ship is bigger. It does have much, much more mass, but it's not all about the mass. It's about how much of this water it's taking out of the way or pushing out of the way. So this volume of water that it had to push out of the way is much bigger for the ship than what it is for the rock. So what is that quantity that we talk about that's got mass and volume in it? Well, that's density. Density is mass divided by volume. So you can have a really, really large mass but have a very small volume, and that gives you a high density. So if you have a large mass and small volume, then you end up with a high density. And what is the density of water? Well, it's 1. So what happens if you have a large mass and instead of a small mass, small volume, we have a large volume? Well, the volume has to do with the size. So if you have a large volume meaning you have something really, really big. It could be massive, but if it's really, really big, then it's going to be starting to push a lot of water out of the place, and so you start off having a pretty small density. And maybe you remember from grade school, from really, really far back, that if your density dips less than 1, then your object's going to float. So the mass is not all encompassing here. The mass is not, if something really, really heavy doesn't necessarily sink or float. It all has to do with how much of that water it's able to push out of the way. So what is the volume of the object? So the buoyant force comes from the actual displacement of water. And has nothing to do with the mass of the thing that goes into the fluid, or I guess I should say fluid here, not just water, whatever the fluid is. Try that again. It's whatever fluid's there and how much of it is that you're displacing. So it does have to do with the size of the object, but not really the mass of it. So you can have something really, really small and sink, even if it's really light, or you can have something that's really, really large and heavy and still float. So the buoyant force here is all about, or is tied to, the amount of fluid that is displaced. Okay, so the amount of fluid that is displaced, that is what the buoyant force depends on. It does not depend on, the mass or weight of the object itself. It has everything to do with what kind of fluid you have and how much of it is being displaced. Okay? Don't forget to answer the questions.